Hello, in this video we're going to be talking about special parallelograms, the rhombus, the rectangle, and the square. So the rhombus is a parallelogram where all the sides are the same. So it is a parallelogram, but all of these sides have the exact same length. So it has all the properties of a parallelogram and it is able to have all of its sides being the same. A rectangle is also a parallelogram, but unlike the rhombus, it has all of its angles being congruent. And since all quadrilaterals have 360 degrees and all these angles are the same, then all of these angles have to be right angles. So a rectangle is not a rhombus and a rhombus is not a rectangle because a rectangle cares about its angles and a rhombus cares about its sides. Now a square is cool. It takes both of what a rhombus and a rectangle does and fuses them together to make this new shape.
Vegeta, let's do this! Fusion! Ha! Bring it!
So a square has all the properties of what a rhombus does and all the properties of what a rectangle is able to do. So it kind of does both. So properties of a rhombus. A rhombus has this property that if you draw a diagonal through it, then the angles here are bisected. And keep in mind that this is a biconditional. So if we've got a parallelogram that has a diagonal in it, it's got to be a rhombus these are cut. If we've got a parallelogram with a diagonal where the angle is bisected, then it's got to be a rhombus. And if we've got a rhombus and it is being bisected, then it is also a parallelogram. So in this example, we know that this is a rhombus because they told us that. So we know that all of these sides are the same. And we know that these have got to be cut in half. So we know that the measure of angle 1 has got to be congruent to the measure of angle 3 because this is getting cut in half. And the measure of angle 4 has got to be congruent to the measure of angle 2. Again, these two have to be cut in half. It doesn't quite look like it, but since they told us it's a rhombus, then that's got to be true. Now keep in mind that even though this thing is a rhombus, it's also a parallelogram. And if it's a parallelogram, then these sides have got to be parallel and these sides have got to be parallel. Since those are parallel, if I look at these two angles right here, 2 and 3, I know 1 and 3 are congruent and 2 and 4 are congruent. Well, hey, guess what? 2 and 3 are alternate interior angles. So that must mean the measure of angle 2 has got to be congruent to the measure of angle 3. So, 2, 3, and 1 are all the same. I wonder if 4 is different. No way. It is also alternate interior angles with 1. So keep in mind, as you're dealing with a rhombus, it still has all the properties of a parallelogram where you've got those alternate interior angle jazz. So we can say that all of these values are the same. So why don't we just keep it easy and call it x? So x, 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 x. We also know that since this is a parallelogram, these two angles have to be the same. So this one's also 69 degrees. Since that thing's a parallelogram, it's a quadrilateral, which has 360 degrees inside of it. We can say 360, our total of our interior angles, has got to equal the sum of our parts. So that's going to be 69 plus x plus x plus 69 plus x plus x. I kind of just started here and worked my way around. And that's a little equation that we could solve. We got 360 degrees equals 69 plus 69 is 138 plus 1, 2, 3, 4 x's. Subtract that 138 from both sides. I get 222 equals 4x. Dividing that by 4, x equals 55.5. So all of these angles in here have got to be 55.5 degrees. Now, a rhombus is not a kite, but a rhombus does share a property with kites, that the diagonals of a rhombus are perpendicular. And this is also biconditional. So if we are looking at a parallelogram and we find that the diagonals are perpendicular, then hey, that parallelogram is also a rhombus. So if I'm looking at this one down here, I know that these are all congruent because they told me that it was a rhombus. So that means the measure of angle 3 has got to be 90 degrees. Using the theorem that we just talked about up here, we know that diagonals of a rhombus cut these angles in half. So I know that the measure of angle 1 has got to be congruent to that 56 degrees. So really, I wrote this wrong, that the measure of angle 1 equals 56 degrees. And that's using that theorem 4-11. I'm not going to write it out just to save a little time. If I know this is 56 degrees and this has got to be 90, I can also see that there's a little right triangle down there. So to find the measure of angle 4, that's got to equal the degrees inside of a triangle minus these two parts. So these two parts. So minus a 90 minus a 56. So the measure of angle 4 has got to be 34 degrees. Finally, if I'm looking at this thing, remember a rhombus is also a parallelogram. So that means that these two angles have to be congruent. So if those two angles are congruent, then the measure of angle 2 has also got to be equal to that 56 degrees because opposite angles theorem. We can use that same logic over here, 53 and 2. Those are opposite angles, so those two have got to be equal to each other. They're also both cut in half from this idea that we've got a rhombus. So the measure of angle 2 over here is also got to be 53 degrees by our opposite angles theorem. We can get the measure of angle 4 right here, the same way that we got our measure of angle 3 over here, that the measure of angle 4 has got to be 90 degrees because diagonals inside of a rhombus are always going to be 90 degrees. To find these two angles, let's do it a little bit better. Let's do our nice total equals parts, because that's really what I was doing over here. I was just trying to shortcut it. So we've got a total of 180 degrees inside of this little green triangle right here. So that measure of angle 1 plus our 90 plus 53 degrees. So moving my way around, measure of angle 1, 90 degrees, 50 degrees. That'll help me figure out what the measure of angle 1 is. Minus a 90 minus a 53, we get 37 degrees for the measure of angle 1. See, I was kind of doing the same thing I did here. I did 180 minus this 90 minus this 53. 180 minus the 90 minus the 56. Finally, we've got the measure of angle 3 right here using this theorem that we used up here, 4-11. That's going to say that 1 and 3 have to be congruent. So measure of angle 3 has also got to be 37 degrees. That's using theorem for 11. I don't have a lot of space. I'd rather write it out like this, but I'm just kind of running out of space, so that's why I'm just writing that. We've done all this talk about rhombuses. Let's talk about rectangles. So rectangles have this property, if and only if the parallelogram is a rectangle, if this red line right here is congruent to this blue line right here. So going all the way across from one side to the other. So that blue is congruent to our red. Now again, this is a biconditional, so if we only know it's a parallelogram, but then we find the diagonals are congruent, that's got to be a rectangle. Uh, if it's a rectangle, then the diagonals have to be congruent. So let's check it out. We want to determine the value of x of in each diagonal. So we got boxes. So why don't I just draw that out? Because I think that'll just help me visualize what's going on. So I'm just going to put B here. It doesn't matter where I put it. I just want to put it somewhere just so I can kind of visualize what's going on. BOXS. So I'm just kind of working my way clockwise around. So we know bx is 5x minus 8. So that's going to be this line right here. And then OS is going to be 2x plus 1. So that is a rectangle. So since that is a rectangle, I know that red is congruent to my blue line. Since red has got to be congruent to my blue line, I can say that that red value has got to be equal to my blue value. So I can solve the equation 2x plus 1. That's got to be equal to the other kind of expression, 5x minus 8. I'm setting those two things equal because I have a rectangle. Now I just got to solve that. So I'm going to minus a 2x. So I've got 1 equals 3x minus 8. I'm going to add an 8 to both sides. So then I get 1 plus 8, that's 9, and just a 3x left on this side. And then I'm just going to divide both sides by 3. So x equals 3. So x equaling 3 will make these two diagonals congruent to satisfy this theorem about rectangles. Last few examples, just kind of wrapping up this idea about parallelograms, rhombuses, and rectangles. Right here, this is a parallelogram, and I'm told that the diagonals are perpendicular. That makes this thing a rhombus. That is using the perpendicular diagonals theorem. So perpendicular diagonal theorem, that means that since that thing is a parallelogram with perpendicular diagonals, it has to be a rhombus. In this next one, we can see that the diagonals are being bisected, and it really does quite look like a rectangle. But I don't know if one of those lines is congruent to the other. So I don't know if this blue is congruent to this red one. I need those two to be exactly the same in order for it to be a rectangle, but I don't know if red and blue are congruent. I just know that red and blue are being bisected, but I don't know if they're the same. Since I don't know if they're the same, they could be, but I don't know. This is just a parallelogram. The fact that the diagonals are being bisected, that's just true about every parallelogram. It's not something special that makes it a rectangle. The rectangle needs those two to be congruent. If I look at this one, I know that these angles are bisected. Since those angles are bisected, this thing has to be a rhombus because that was the first theorem that we looked at. That was the angle bisector, diagonal angle bisector theorem, whatever you want to call it. But the fact that this is being bisected and this is being bisected, that means this thing has to be a rhombus. That is something true about rhombi. And that's it for this video. So look for those angles being bisected or the diagonals being perpendicular. That makes that thing a rhombus. And for a rectangle, you want this blue and red line to be congruent. If you don't know that, then it's just a parallelogram. If you don't know they're perpendicular, it's just a parallelogram. And if you don't know if these are being bisected, it's just a parallelogram. Thanks for watching. Bye bye.